I'm Omar Kamran. So today we'll be talking about solar and wind energy. So solar and wind energy are two types of renewable energy sources. But that begs to ask the question, what exactly is the purpose of renewable energy? So on this planet, we have fossil fuels and natural gas, which was already found on Earth. And they are our main sources of energy for all sorts of things, electricity and everything else. They are dominating the energy market. But there are two big drawbacks to these natural gases and fossil fuels. One is that they're non-renewable. The amount that we started off with is not gaining more, so eventually we're going to run out. And then second, it's very harmful to the environment. Burning of fossil fuels and natural gases release CO2, which is carbon dioxide emissions, into the environment. This is the cause for air pollution and holes in the ozone, which is a major factor in global warming. So that's where solar and wind energy come in. These are the two main, most popular sources of renewable energy and clean renewable energy that doesn't harm the environment. So let's talk about them in just overall. Solar energy is derived from sunlight. They use solar panels that take in sunlight and absorb it and convert it to electricity. And then wind turbines are, as you can guess, is from their source of energy is wind, the flow and wind flow. And it takes the wind's kinetic energy and converts it to mechanical, which in turn converts it to electrical. So let's go more in depth with solar energy. We're looking at the systems and devices that are used in solar energy, right? As I mentioned before, it's the solar panels. These solar panels they're also called photovoltaic panels, right? These are made up of photovoltaic cells, which is the process in absorbing sunlight and converting it to electricity. What it does is it separates the atom from the electron, which generates electricity. So engineers have designed what they call a collector plate, and it has these metallic fins. And this is a new design in solar panels that is it's an endothermic board with a glass cover optimized to increase heat transfer. The design of this double layer prevents heat loss. These collector plates, as I mentioned, have these rectangular fins which regulate flow of the heat, right? And it is better for the convection. Now, but it does have a few drawbacks to it, right? What the problem is when it kind of has a lot of clutter and it's not really form-fitting. So that's where the next thing comes in. Hybrid devices. Hybrid devices were made after the whole problem with collector plates. What exactly hybrid is, it combines the process of charging and supplying energy, puts it into one. So it removes the use of wires and a battery pack. So it's more form-fitting, more slim. And it comes in three types, right? 2 electrodes, three electrodes, and 4. Now, the 2 electrodes the problem with 2 electrodes that it can't do 2 different things at once, right? It's either going to store energy or it's either going to supply energy. So think of it more as a storage unit rather than supplying. The 3 electrode it solves that problem and it can do both at once. And then the 4th electrode is more of a system than a device, which is why system and devices. And it's used for large scale things, for large corporations and businesses and things of that sort. But then it comes to the cost. How much does this all cost? Well, as you can see, on average, 4 kilowatts is about 15 grand, right? So the cost of solar energy is quite pricey, but that's what we have to figure out. So at KNUST, which is a university in Ghana, they conducted a case study and tried to use solar panels at the university because they were using a lot of electricity in the city of Ghana, and it was giving them really, really high electricity bills. So there is a total potential about 163,400 kilowatts per hour. This translates to about 37 grand, almost 38 grand per month in electricity cost savings. So the use of solar panels is cost-wise, it is quite pricey, but it's what we need for clean energy rather than fossil fuels or anything like that. Then we look at its counterpart, which is wind energy. we look at the system of wind energy, right? Wind energy is converted by wind turbines. Wind turbines have four main components. As you can see in this picture, this is what a wind turbine looks like. So it has a foundation, which is the base, the tower, the nacelle, which is the compartment in the wind turbine that does the actual conversion, where it converts the kinetic energy of the wind to mechanical to electrical, and then has three blades. Now, the wind turbines on average are about 80 feet tall, and it's very imperative for wind turbines that their geography is catered to them, because the obstruction of wind will obstruct to wind, the flow of wind. The foundation is made out of concrete, the tower and the nacelle is steel or metal, and the carbon fiber material, the blades are made out of a composite material. So let's talk about the cost of it first. So the cost of wind energy, the problem with it, well, first let's look at this table. It tells you the cost per component, and it has the weight per component. So the fixed cost is how much it will be based on manufacturing and transportation, and then variable cost is how much it is per weight. As you can see, they're very heavy components. Now, the drawback that comes from the cost is that it requires a lot of maintenance as compared to solar energy. Because it has moving parts, it requires frequent checkups, and also the material used to make the blades is a composite material, right? Now, composite material is non-recyclable, so that will eventually end up in a landfill. So it said in just 2020 alone, it was estimated that 50,000 tons of waste was built up by the composite material of blades, and engineers and scientists fear that by 2028 this could be a global problem. So the solution to that was carbon fiber. Carbon fiber is a good material to use for the blades, but also very, very pricey and a very high initial cost. This is an equation that they use to find the annual production cost model, right? The APC. The FCR times ICC plus AOE. So that's the equation used to find it. And then so after this, to really put wind energy in an actual experiment and study, in the city of Ma'anshan in southwest China, there was a case study done. They have a wind farm there, and what they did was they compared the two turbines, and they did the LCO, which is the levelized cost of energy. The levelized cost of energy is almost $52 per megawatt hour, which is really pricey because it's at a high altitude. Right? So this kind of goes into what I mentioned earlier, that wind turbines have to cater to their geography, right? You can't just place a wind turbine anywhere. So that's why we get to the recommendation. The reason I have solar energy as a more viable option than wind energy, they both have their drawbacks and they both have their good. They're both better than fossil fuels, right? They're both clean sources of energy. So it gets down to the efficiency and the cost. Now, solar energy has no moving parts, so it requires less maintenance. A wind turbine is almost 80 feet tall. You need to worry about geography, and you have more work and maintenance. Price for wind require more frequent repairs, but solar is more applicable. Right? It's more, think of it as solar is more residential and wind is more commercial or industrial. You need open land, and having a wind turbine is also a threat to birds. It's noisy, and so it's not really a suburban type thing that you can have near your house as a source of energy. Right? Maybe if large corporations who are out in the field or in like large plains, then I understand how wind turbines would be a more beneficial source of energy for them rather than solar, because they are both pricey in their own way. But because wind requires the price in bulk, it might be a little cheaper because you're getting it all at once, whereas solar is cheaper in terms of small quantities. So because of the small quantity, that's why I feel that solar panels and the use of solar energy would be more viable in a residential state. And also wind turbines, they require a minimum of at least 7 to 8 miles per hour for it to start generating. And the most it can get to before it stops and it's too much wind is 55 miles per hour. Now 55 miles per hour is a lot. That's like a tornado or something. But these type of things have to factor in. There's a lot of geographical factors that follow in that solar doesn't really matter too much, right? Whereas solar panels, the thing is, since it is sunlight, during the nighttime you're not getting much sunlight harvesting, but that's where the hybrid thing I talked about earlier came in. Their storage and charging station stores enough energy for it to last during the nighttime and then continue charging when the sunlight is out. Although wind is 24 hours, I feel just the process of the maintenance, the work, and just the sheer size of it alone, it would be more useful and viable to go with solar panels as the use of renewable energy. Thank you.